So now with right triangles, you know how to solve for a missing side when you know the two other sides. And now you also know how to solve for an angle when you know two other sides. This last video for right triangles is going to be about how to solve for a side. Now to solve for an unknown side, you have to know an angle and one of the sides. If you know this, you can solve for a missing side in a triangle. So here we go. Forrest Green was trying to figure out the height of a tree. He determined that the angle of elevation to the top of the tree was 35 degrees. He measured his distance from the base of the tree and found it to be 10 feet. What is the height of the tree? So you're not always given the picture. Sometimes you have to draw the picture. You've got Forrest Green. He's trying to figure out the height of a tree. He determined that the angle of elevation to the top of the tree. Now I know in a real scenario, he'd be looking from his eyes. This is just a, let's start these questions. So we're finding the angle of elevation from his toes. Okay, so he finds that the angle of elevation, which is an angle from the horizontal up, is 35 degrees. He also measured his distance to the base of the tree and found that it was 10 feet. He wants to know the height of the tree. So the first thing we've done is draw our triangle so that now we can label our triangle. That's always, always, always your first step when you're solving a right angle triangle. So this is my right angle here. So from that right angle, this is my hypotenuse. From this known angle of 35 degrees, this is my opposite. And then my leftover, or my angle beside my 35 degrees, is my adjacent. Now I have to figure out which trig ratio to use. I'm going to decide based on which one has things written on it. So I want to solve for x, which is my opposite, and I know my adjacent, which is 10. So opposite and adjacent means I'm going to use TOA. So I'm going to set up my trig ratio as the tan of an angle theta, which is just a generic angle, is equal to the ratio of the opposite to the adjacent sides. Now I'm going to fill in what I know. This time I know that the angle is 35 degrees. I don't know the opposite, but I know that the adjacent side is 10. And I'm trying to solve for x. So again, if you're a y person, what we're going to do is type into our calculator tan 35. If you do that, that gives you your ratio. So if I type just tan 35 into my calculator, it gives me 0.700 ... And so what your calculator, or what we're trying to figure out, is what value x will give us this ratio of 0.7 to 1. So if anybody can think about that, your calculator should give you a 10 as an answer, okay? Because it's saying what to 10 would give me a ratio of 0.7. Now we never, ever, ever sort of write down all this work. What I would do instead is just let my calculator do its work, which is to solve for x. So algebraically, to solve for x, I want to get rid of this 10. So I'm going to multiply by 10, and I'm going to multiply both sides by 10 because I have an equation. So I'm going to say that x is equal to 10 times the tan of 35, and that will tell me what value out of 10 will give me a ratio that's the same as any tan 35 ratio. So if I type in 10 times the tan of 35, that's going to give me 7. And it says to the nearest, it doesn't. So I always, when it doesn't tell me, I always go to the nearest tenth. Another rule of thumb is you can say, well, this went to set 10 feet, so you could say 7 feet. If you're taking any science courses, that would be answering with the correct number of sig figs, right? So it's 10 feet, so we would say that it's 7 feet tall. If it doesn't specify how many decimals, whatever you answer, I will take as correct. But we have now used trig ratios to solve for an unknown height. Let's try the next one. So the next one, I have the picture drawn for you. So this is less word problem-y. So I want you to pause the video, and this question is asking you to solve for side C. So the first trick is to figure out, well, which one is side C? Little c is always across from big C, so this is going to be my little c here. Okay, pause the video and see if you can figure out what trig ratio to use and then how to solve it. Okay, so hopefully you paused your video and then you are just coming back. So here we go. We are looking from this angle 40 degrees. My first step is always to label my sides. So we've got hypotenuse always across from the 90. Across from this 40, I have my opposite, and then beside it, I have my adjacent. To decide which trig ratio to use, I figure out which sides have things written on it. So my hypotenuse and my adjacent do. So adjacent and hypotenuse means I'm going to use ka. So now I'm going to set up my trig ratio. So the cos of any angle is equal to the ratio of the adjacent side to the hypotenuse side. For this question, it's the cos of 40 is my angle, is equal to, now my adjacent side is 6, and my hypotenuse is c. I want to solve for c. If you've done these for a while, you might know that I look at these and I think bait and switch. I just put this up and I put this down. The reason why is to solve this, think of your rational expressions. I'm going to multiply both sides by c to get rid of my fraction. I end up with c times the cos, I'm going to put times there because it's weird having two c's, of 40 is equal to 6. Now to get c by itself, I'm going to divide by the cos of 40. And I end up with c is equal to 6 divided by the cos of 40. So that's the best way to show your work. In reality, what I end up doing is thinking this. The c comes up, the cos 40 comes down. Okay, but to plug this into your calculator, you just simply type 6 divided by the cos of 40. You hit equals, and you get to the nearest whole number, this question says. It's 7.8, so I'm going to round it to 8. So again, what this question did, kind of, I can't stop myself from doing the y's, is it went, okay, cos 40, what is the ratio for cos 40? So the ratio of cos 40 is 0.766. So it's saying 6 to what side length would give me this ratio? And then I solved it algebraically. Awesome, so hopefully you're feeling pretty confident with your trig ratios, either to use them to solve for an angle or to use them to solve for a side. And don't forget that Pythagorean theorem exists. If you know two sides, you can always find the third using Pythagorean theorem.